Hey everybody, welcome to Extreme Coder. Today we bring something different. Today we're gonna talk about computer graphics technology. It's about the global illumination. In computer graphics, lighting is the biggest asset when developers creating beautiful graphics works. The real talk of the lighting turns out these days through this global illumination, or we call it GI. But what exactly it is, how does it works, if it could be the future of lighting in computer graphics, let's find it out. Global illumination is a general name for a group of algorithms which is used in 3D computer graphics that are meant to add more realistic lighting in 3D scenes. It's a name of a process that simulates indirect light, like light bounce and color bleeding. Global illumination is an important part of 3D animation and design that helps give it a more realistic feel. Without global illumination, objects simply would look like in certain cases, which would lead to pulling the audience out of the moment. If we look at the example here, we're gonna see that the green color of the wall is being cast on the sphere on the right side of the image. That effect is referred to an indirect lighting because the green light isn't being cast directly from a light, but rather is a result of a white light being cast in on the green wall, which is then bleeding onto the nearby spheres. Global illumination plays a big role in getting this distinctive and often necessary look. Let's make it a little bit more easier. Here, this comparison is between computer-generated lighting and a traditional lighting. Here we can see on the screen two same scenes. On the right side, which is filmed in a studio, and the left side, the scene is created by computer, which is a digital scene. In both scenes, bright spotlight shining on a white flat surface. What happens if we put something in front of the light source? In both cases, the rectangle casts a shadow. Well, on the left side, on the computer generated scene, when the light is blocked, the resulting shadow is totally black, a complete absence of light. In real life, that doesn't happen actually. It because light bounces. It bounces off walls, it bounces off objects, and these bouncing lights makes the shadow a little bit brighter and lighter. This extra bounce light is what global illumination brings to the computer generating lighting. Well, let's find out what expert has to say about global illumination.
Well, global illumination isn't actually particular to computer games. It's a set of tools that are available, if you like, to artists to simulate the bounce and the interaction of light and surfaces in the real world. In the real world, light comes from a source, it hits a surface. From that surface, it then diffuses and bounces onto other surfaces, taking with it properties like color.
So first of all, it's a tool that artists have to just light their levels more easily. For example, you add a sun to your level, right? And I have an indoor area, and rather than having to add lights in myself to try to simulate what that bounce light is, I can just have the sun add all that bounce light automatically. New upgrades.
What graphics designers are essentially doing with GI is mimicking how light behaves in real life. Although it's not quite accurate, but what they're doing with the GI that is really extraordinary.
The problem with games is that you have to do this 30, 60, 100 times a second to sort of achieve playable frame rates. So a lot of the work will actually be handled offline. We use light maps commonly as a technique for baking GI. So that is pre-computing the bounce of light and then writing that onto a texture. That unfortunately is static in many cases, and that's the real innovation of the current technologies that are available, is that they allow you to do this manipulation. We can actually change the the qualities of the light. We can move the lights around and we can see the effects of that in real time in the game.
The way they're built, first with many cores and a lot of memory and very programmable graphic chips. There's never before been so much possibilities to do things like global illumination. And in our case, the Division is coming out for PS4 and Xbox One, and it takes advantage of the hardware to the fullest, and we can achieve a really amazing look with global illumination.
With Unity 5 they can. We now have Enlighten out of the box, which means that artists can exploit the technologies that are now available to change the lighting in their scenes much more realistically at render time.
You can see Fable Legends running on Xbox One using light propagation volumes in UE4. And there are some other solutions that sit somewhere on that range from the fully dynamic solution of LPV and the fully precomputed solution of light masks. We're all trying to search for this one solution that's going to be fully dynamic, that will work in just the general case, get super high quality, and be practical on this generation. I don't think we found that yet, but we're all trying, right?
So that's what the current generation technology can give us now in terms of lighting. Let's finish by looking forward and ask what the ideal feature might be able to offer us.
I mean, ultimately, we want to be able to just procedurally generate a world, blow a hole in a wall, right? You open a door, you can see the sunlight spilling into a room. You want those interactions with light that you expect to just work, right? And from the point of view of building a world, you want to be able to take a light and just drag it into the level and move it around, and all of the bounce lighting is updating in real time, dynamically. That's where we want to get.
The nirvana, if you like, of games, I think, is when we have the hardware and we have the computational power available to us to actually do real-time ray tracing on the fly, where anything can move because we're just rendering photons bouncing around and hitting a camera. If a player moves through the room, the colours from his outfit are actually affecting the colours on the surfaces around him, actually doing that, rather than using the techniques that we have to use currently to simulate that effect.
Well, that was all about the global illumination in this video. Hope you guys like it.